Okay, this question I'm going to look at today is from June 2023, Edexcel A level again, but the second pure paper, and it's question 11. Now, this is a differential equation question where you have to form the differential equation first. So it's quite a classic equation where you have to kind of build things together, all the information they give you, find a differential equation, and then go ahead and solve it and use it. So, part A, we have this situation where we have this tank being filled with water, and its dimensions are 20 by 10 by 5. The tank initially is full of water up to a level H. It gives us some conditions and everything for this in a bit, but we'll just deal with the first bit. So it tells us that the sides of the tank have negligible thickness. So basically that means the dimensions you see is equivalent to the volume. You can't go, oh, hang on, it's 5 this way, 20 this way, 10 this way. But isn't it thickness? So therefore actually the inside dimensions are less than 20 or less than 10. You can ignore the thickness of the tank, and so therefore those are the true dimensions that we're going to use for the volume. Okay, so we can ignore that, and then it says the rate of change of V is inversely proportional to the square root of H. I'll come back to that sentence in a second. And what we need to do is show that dH by dt is equal to lambda over root H, where lambda is some constant. Okay? So, let's go back to that sentence I just said there. The rate of change of V. So the rate means something dt. So the rate of change of time, something changing with time. So as soon as you see that word rate, it's to do with time. And you know you're going to have a dt on the bottom basically in most of these situations. So the rate of change of V is basically dV by dt. The rate of change of the volume with time. Okay, and it's inversely proportional to the square root of H. So we should know that that is equal to K over root H. Because inversely proportional means 1 over. We don't need to put the proportional sign in there. We can go straight to the equation. And we know it's going to be, for inverse proportional, it's going to be some constant times 1 over, in this case, root H, because it's the square root of H that it's inversely proportional to. So there's your first equation straight away, and you're going to get some marks straight away for putting something like that down. Now, we haven't got dV by dt that we're trying to make it look like that. We want dH by dt. So with all these questions, you have something to do with the rate of, in this case, the volume, but you also have some connection between V and, in this case, H. And that connection will usually be a formula that links the two. Now in this case, the volume is all about how much water is in there. And we can see there's a nice little formula for the volume of water in there. We know it's just a cuboid that's 20 by 10 by H high at that particular time. So we're going to use the fact that V equals 20 times 10 times H. So that is simply V equals 200H. Now then, we're going to use a little bit of chain rule here. We want to find out what dH by dt is. And there's loads of ways you can set this up. Some people like to go down this route and say, right, well, I know dV by dt. I can work out what dV by dH is, and then dH by dt's will cancel, and that will be equivalent to dV by dt. So it's setting up this little kind of chain rule here so that you can see dV by dt is dV by dH times dH by dt. You can have this kind of formula though in any formation you like if you want. If you think, oh, I want to find dH by dt, you can start with dH by dt equals and set this up. But you want to see some cancelling so that it works. dV by dt, the dH's cancel. So I prefer to kind of set up that, I know that, so let's stick in this. Now, dH by dt is what we're trying to find. dV by dt, got it up there. dV by dH, we need that. So we go to our formula, V equals 200H, and we're going to differentiate that. So we're going to differentiate with respect to H. So dV by dH equals, and this is quite a nice one, 200h differentiated with respect to h is just 200. Yeah, just simple differentiating. Now we've got all the components, we can just stick it in. So dv by dt, k over root h. dv by dh, 200. dh by dt, dh by dt, that's what we're trying to find. So now all we need to do is divide by 200, don't we? So we're going to have k, now I'll tell you what, I'll write it like this to make it more obvious. K divided by 200 over root h equals dh by dt. Now, we've used k as a constant up here for our proportional sentence they use, inversely proportional to. In what we're trying to prove, they just say they got a lambda up here, which is some constant. Well, we've got a lambda up there, it's just that we've written it as k over 200. That is still a constant. So with these particular questions, sometimes you get this situation where what you end up with, you've got something here that is a constant. K is a constant, divided by 200, it's still a constant. So it's some constant over root h, and they're just calling that constant lambda. So therefore, dh by dt is what we want, lambda over root h, where our lambda is k over 200. Okay, done. Nice and simple. So that's a nice 3 marker. And it's usually the same old question. Rate, so dt, get out your equation linking v and t, dv by dt. There will be some formula, they might give it to you, or it might be one that you have to quickly work out yourself using, in this case, volumes, that you might have to differentiate, and then this. Now, any doubts at all, I would write it out like this, dv by dt, what I know, and then go right. So dv on the top, dt on the bottom, and the thing that I'm trying to include, the h's there that will cancel, and then just plug in everything and a bit of rearranging. Right, okay, so we proved that. We are now going to solve that, it looks like. So there's our part A done. So part B says, excuse me, I'm just going to get it back up on my screen so I can see it a little bit clearer. Use the model to find an equation linking h with t, given your answer in the form, so we're aiming for this, h to the 3 over 2 equals at plus b, where a and b are constants to be found. So what they're basically saying there is, let's start solving this. So h by dt equals lambda over root h. Okay, so it's solving this differential equation. They give us some initial conditions as well, which I'll come back to in a minute. They talk about initially the height of the water in the tank, and then after 8 minutes, the water started flowing in the tank at the height of the water was 3.24. So we'll come back to that in a second, because we're going to use those to find out our constants. But anyway, so differential equation, dh and dt, so we want dh on one side, dt on the other, anything to do with h over with the dh, anything to do with t, which we haven't got at the moment, but that's fine, over on the other side. So I'm going to take that dt over that side, take that root h over that side, so I'm going to have root h dh equals lambda dt, and I'm just going to integrate both sides. So here, root h, well that's obviously h to the power of a half, so we integrate away there, add 1 to the power, divide by the new power, so we add 1 to that, it becomes 3 over 2, so it's going to be 2/3 h to the 3 over 2 equals, now lambda is just a constant, it's just like integrating 7 or 17 or 7 million or whatever. So when we integrate lambda, it's just going to give us lambda t. But we get a constant of integration, so plus c. Now you don't need a plus c on both sides, it's kind of like, technically there's a constant there, there's a constant there, but they combine to give us just one constant. And we can just leave it as one constant, because if you have a constant there and a constant there, well, take that over there and you've just got one constant. So we just have the plus c there. Now, we've got 2 things we don't know. We don't know the lambda from our original equation, and we don't know the c, but we're given some conditions. So the first one is that the height of the water in the tank was initially 1.44. So initially, that means when time was 0. And we know the height was 1.44. So there's condition number 1. So we can stick that in to our equation. So we're going to have 2/3 times h, 1.44, to the power of 3/2, equals lambda t, well t is 0, so therefore that disappears nicely, and it gives us our c. So into our calculator, 1.44 to the power of 3/2, so that's 1.2 cubed, but I'll make sure that I don't make a silly mistake. I will actually put it into my calculator, or I will go and see what the answer was that I originally got. Just searching for this at the moment. 1.152. We end up with C. Okay? So, now we found what C is. But they give us further initial conditions because we don't know what lambda is. And the, not initial conditions, sorry, there's further conditions. Exactly 8 minutes after water started flowing to the tank, the height of the water was 3.24. So 8 minutes, t equals 8. Height is now 3.24. So we just stick those into this now with our c being 1.152. So it's going to be 2/3 h, 3.24, to the power of 3/2. Equals lambda t, well t is 8, so 8 lambda, plus c, which is 1.152. So we have ourselves another little equation. Out comes the calculator again, plug it all in, take the 1.5, divide by 8. I'm sure that's what all A-level mathematicians, we can do that kind of thing. And again, I'm going to have to lean over here and find out what that is. It gives us lambda being 0.342. Save me putting it into my calculator. Okay, so we now have an equation. We've got 2/3 h to the 3/2 equals lambda t, well lambda being 0.342, plus c, which is 1.152. Don't lose a mark at the end though, they want it in this form. So we just got h to the 3/2, well there's our h to the 3/2, so we're going to have to divide over by 2/3 to get our final answer. So our final answer will be h to the 3/2, divide the 2/3 into both of those, and we get a final answer of 0.513 t plus 1.728. Job done. Okay, lovely little 5 marks there. Okay, so, and as is typical with this kind of question, now you've got yourself an equation, they want to see you use it. So it says, hence find the time taken from when water started flowing into the tank for the tank to be completely full. Well, if the tank's completely full, all the way up here, doesn't that mean that our h will be worth 5? So we're basically saying, work out when h is 5. So for part C, I'll leave that at the bottom because I'm going to use that equation. We are simply going to stick in h equals 5 into our equation. So 5 to the power of 3/2 equals 0.513 t plus 1.728. And again, with further with A-level mathematicians, we can solve this. So in your calculator, take that over there, divide by there. We should be able to do that. And we get our t value. And I'll just tell you what that answer is if I crawl across here. Apparently 18.4. Now, for the tank to be completely full. That's it. Done. Okay, so nice little differential equation there, but the whole setup as well, which is quite a typical kind of question you're going to see. There we go.